Hello, my name is Calista Mitchell, and for my chemistry project, we will be going over all about acids and the characteristics they possess. Our learning objectives for this presentation will be for you to understand what an acid is through a concise description, learn the characteristics they possess, review an example of an extremely strong acid, and read through a real-world example. So, what is an acid, you may ask? An acid is defined as any substance that contains one or more hydrogen atoms that, in a solution, are released as positively charged hydrogen ions. Some characteristics of acids include a sour taste, corrosive, which means it burns the skin, and some are toxic. A pH of less than 7 changes the color of certain indicators like the reddening of blue litmus paper, seen in the photo to your right, reacts with bases to form water, and reacts with some metals to produce hydrogen gas. Some examples of acids include black coffee, lemon juice, nitric acid, and hydrochloric acid. So now that we know what acids are concisely, let's look at an example. Sulfuric acid is an extremely strong, colorless, oily liquid, also known as H2SO4. The molecular structure is shown to the right of your screen, which shows 4 oxygens, 2 of them which are double bonded to the single sulfur atom in the middle, and the oxygen atoms are attached to 2 hydrogens. This acid is soluble in water with the release of heat, and is corrosive to metals. It will char wood and most other organic matter on contact. We know this is an extremely strong acid due to its low pH level of 0.3. It is corrosive and toxic to humans and can cause adverse health effects if ingested, inhaled, or put on the skin. Some human uses of sulfuric acid include the manufacturing of certain fertilizers and other cleaning chemicals. Sulfuric acid may be included in some pigments, dyes, explosives, detergents, and inorganic salts and acids. It is included in petroleum refining and serves as an electrolyte in lead-acid storage batteries. Even though sulfuric acid does not exist purely in nature, volcanic activity can result in the production of sulfuric acid depending on the emissions associated with that specific volcano. Sulfuric acid aerosols from an eruption can persist in the stratosphere for many years and cause health effects in the lungs of people in the area. Now let's look at a real-world example of how a low pH level can affect a soil solution. In the world of geology and soils, non-silicate aluminum and iron oxides are organic clay-sized particles found in highly weathered, well-drained soils in warm, humid, and subhumid tropics. The overall positive charge of the soil colloid is highly dependent on the acidity of the soil solution, meaning it won't have a positive charge if there's not a low pH level. Some examples of minerals that possess non-silicate aluminum and iron oxides are hematite, goethite, and gibbsite. In our chemical equation below, the hydrogen plus ions from an acidic soil solution are attaching to the structure of gibbsite. This gives the soil colloid as a whole a net positive charge. And since the colloid is positive, it acts to retain anions. This gives the soil colloid as a whole an anion exchange capacity, also known as an AEC. In conclusion of this presentation, we learned that acids are defined as any substance that contains one or more hydrogen atoms that in a solution are released as positively charged hydrogens. Acids always taste sour, are corrosive, with a pH level of less than 7, reddens blue litmus paper, and reacts with bases to form a neutral solution of water. Sulfuric acid is an extremely strong acid with a pH level of 0.3. It is used in cleaning chemicals, fertilizers, petroleum refining, and in storage batteries. And non-silicate aluminum and iron oxide's overall positive charge depends heavily on the low pH of the solution.